recall, value numbering can optimize away this expression since it's fully redundant. However, here we destroy the value of the expression since we give it one of its operands a new value. And therefore, this occurrence of the expression cannot be optimized away by value numbering. As we will see soon, it can be done by PRE. Okay, so the key idea is to introduce a new variable. I should first mention that the Silicon Graphics compiler does not use 3-address code statements, but instead expression trees. And therefore, it is needed to introduce a new variable. We use this new variable even though we use 3-address code. But the implementation can be adapted to simplify this, since we already have a variable in 3-address code. Okay, so the reason why this is called H is that this is a hypothetical variable. And when we assign, when we compute this expression, we simply save the expression to this variable. There, and there. And also here. What we do here is we destroy the value of a plus b since we overwrite a. And what we actually do is, what is done in SSAPRE is to invent a new value called bottom, which means it's not existing value is what it means. We can give h the value bottom when a plus b is not available, such as here. And that's really the key and beautiful idea with SSAPRE. So since we have an assignment to h here, we need a phi function for h here. This phi function uses capital Phi, and it is used essentially in the same way as the normal phi functions, but to see which one is which, we use capital Phi instead. And then at the end of SSAPRE, they are, how the implementation marks this as big or normal phi function is irrelevant, but we translate these to normal phi functions. So essentially, they are really the same. Anyway, what is needed here is that what is important here is that we can take these phi functions and see where we can insert the expression to make this a plus b fully redundant. And it turns out that whenever there is an operand to this phi function which has the value bottom, then it might be a good idea to insert a plus b here. We will see exactly why and when later, but this is the real key idea to SSAPRE. Where the value is not available, we have a bottom valued operand, and for some of these we insert the expression. Create an instruction which computes a plus b. And then subsequent a plus b might be redundant and can be eliminated. Of course, it's necessary to keep track of which variable version we have. Okay. So, SSAPRE performs the following steps for each expression in a function. So it's quite a lot that is performed for each I mean, for every expression, I mean unique expression, where we have a variable plus, I mean some operator and another variable. And this is a case where we actually need to know which variable this is. I said previously that when we translate a program to SSA form, the renamed variables, they can just be temporaries. But SSAPRE needs to know which ones are which. I mean, what they originate from. So it's not sufficient to only say temporary 1 plus temporary 2, etc. We need to know that they are from A and from B. Okay, so the first thing we do is to insert such phi functions. And where should we insert them? Well, it is in the dominance frontiers of the expressions. Okay, since that is where we assign a value to h. Okay, then what we do is to redo SSA renaming for this variable and for all other variables again. This is not part of the efficient algorithm, but it's just to explain what can be done. But the efficient algorithm just keeps the renamed variables and their indices and figures out when which expression is available with which version of the operands. Okay, so what we then do is to compute something called down safety. And the purpose of that is to be sure that we do not insert the expression unless it's certainly needed. Okay, we will come to that. And what we do then is to compute for which such phi functions the expression can be available. Okay, in order to reduce the extent on which a temporary variable is needed to be put in a register, we try to do this as late as possible. So for each phi function, there is also a computation of an attribute called later, which means we can do it later on in the program. We don't want to do it as early as possible at the beginning of a function, since that would be a waste of register resources. And then in 2 steps, we modify the code. The first step is what we will look at. The second step is a bit tedious and is best studied when you implement the code. Okay, so we will not look at it at all, actually, in this lecture. It's not complicated, but it's just tedious. Okay.